In this video, we're going to talk about how to solve systems of linear equations using the elimination method. Sometimes this is also called the addition method. Okay, so let's go ahead and get started with this first one. So for the first step, we're going to eliminate y. So why am I choosing y and not x? Well, I can see that if I were to add these two together, these two equations together, y would get canceled out. Alright, so let's go ahead and do what I just said. Okay, so first step is eliminate y. So I'm going to take 6x minus 2y equals 0. 3x plus 2y equals 18. I'm going to add these two together. So I'll have 6 plus 3 is 9x. Okay, these cancel out, so that's 0, y equals 18. Okay, so now I can solve for x easily. So divide both sides by 9. So I'll have 18 divided by 9 is 2. So x equals 2. Alright, so first step is to eliminate one of the variables, and then the second step is to use back substitution. Okay, so 2 is called back substitution. Alright, and so to do that, I'm going to choose either equation, doesn't matter. I'm just going to plug in x equals 2 and solve for y. So I'll choose the first equation. So it's 6x, 6 times 2, and then 2y equals 0. Alright, so that's 12 minus 2y equals 0. I'm going to subtract 12 from both sides. Divide both sides by negative 2. Y equals 6. Okay, so what's my solution set? 2, or this is a point, 2 comma 6. Okay, I can check my answer by just plugging this point back into both equations and checking that they, that if you plug it in, you get 0 on this side and you get 18 on this side. I'll leave that to you to do. So let's go ahead and we'll do another example. In this example, we don't have a variable that we can easily eliminate like we did in the last one. So instead, what we're going to do, we have to kind of manipulate this in some way so that something can be eliminated. It doesn't matter what variable you choose to eliminate; just choose one of them. So I'm going to choose to eliminate x. Okay, you could have also chosen to eliminate y. All right, you'll get the same answer. So if I want to eliminate x, if I were to multiply this by 3, I would then have 6x, right? And then if I were to multiply this by negative 2, I would have negative 6x, and then these would eliminate. Okay, but I can't just multiply this term by 3. I need to multiply the entire equation by 3. So let me go ahead and write that. So I'm going to multiply everything up that's in the top, the first equation, by 3. So everything, include right and left side. Okay? And then on the bottom, I'm going to multiply everything by negative 2. Okay? And so let's go ahead and do that. So then let's see what I'll have. So I'll have 3 times 2 is 6x plus 6 times 3 is 18. 18y minus 3 times negative 3 is negative 9. Then on the bottom I'll have negative 6x. Negative 2 times negative 12 is negative 24y. And then negative 2 times negative 18 is negative 36. Okay, now I'll do the addition. So these cancel, and 18y minus 24y is negative 6y. And negative 9 minus 36 is negative 45. So divide both sides by negative 6. I'll have 45, the negatives cancel, 45 divided by 6. Let's see, both those are divisible by 3, so that's 15 over over 2. Okay? Alright, so y equals 15 over 2. So the second step is to do the back substitution. So let's do the back substitution. And so to do that, I just choose one of the the equations, doesn't matter which one, and then solve for x. Alright, so I'll choose the top one. So I'll have 2x plus 6, and then y is 15 halves, equals negative 3. Okay, this 2 cancels with that 6, and the 6 then becomes a 3, right? Because 6 divided by 2 is 3. So then this becomes 2x plus 3 times 15 is 45, equals negative 3. And then subtract 45 from both sides. So I'll have negative 48. And divide both sides by 2. So that would get a negative 24. Okay, so what's my solution? X is negative 24, and y is 15 halves. Okay, again, it's a very good idea to go back to your original system and check that this point satisfies both equations. But I'll leave that to you. Okay, so let's go to one more example. Okay, so in this example, the very first step is that we're going to need to line things up as they have been already usually in the other 2 examples, or they were in the other 2 examples. Okay, so the very first thing is to rewrite this. So what's on top is fine for the first equation, but on the bottom I want to line it up so I have the x there, and I'm going to go ahead and bring over the 4y by adding 4y to both sides. Okay. Right? So if I added 4y, this cancels, and then I end up having x plus 4y. That's what I mean by lining it up. You want to make sure you have everything lined up. So similar terms are on top of each other. Okay. So this is our system now. So first step is I need to do an elimination. So I'm going to eliminate x. I think is probably the easiest thing to do. So I'm going to eliminate x. So to eliminate x, I'm going to multiply this bottom by positive 2. Right? If I multiply this by positive 2, then this will cancel. So let's go ahead and do that. So on top, I'll have negative. I'm not changing the top at all. Okay, but I'm going to take what's on bottom, and I'm going to multiply everything by positive 2. Okay, so the top not changing. In the bottom, this becomes 2x. 4 times 2 is 8, so plus 8y. And 5 times 2 is 10. Alright, this cancels. Oh my. So does that cancels as well. And so does this. So what do we end up with? We get 0 equals 0. Okay? And that is true of any value of x. Right? So this is always true. 0 always equals 0. So this is a consistent equation, but it's one of those equations that has infinitely many solutions. So remember the way we write our solution when we have infinitely many. We first start by saying that x, and then we write what y is in regards to x. So I need to solve for y. I'll go ahead and use this bottom equation to solve for y. So if I were to do that, I would have, well actually, let's look here at this equation here. So let's go ahead and we'll take 4y equals 5 minus x, and then y equals 5/4 minus 1/4 x. Okay, so that's the equation for y. So we just write that here, 1/4 x. Okay, and it's all of these for any x. It's this line. And that's your answer.